Welcome back. I hope you've enjoyed your day so far. And now the last speaker for today. We have two young gentlemen joining us from Canada remotely. That is Jean-Pierre and Kevin. And they're going to talk about the solution that might help us, and actually is helping us, on analyzing and understanding the malware. All right, gentlemen, welcome to the studio, welcome to the CERT.LV, and the cyberspace is yours.
Maybe I should say good morning or good afternoon, I guess, for you guys. We're live from Canada here. So I'm Jean-Pierre Vigneault. I'm the team lead for the malware analysis automation team in the Canadian Cyber Center. And with me, I have Kevin HardyCooper, who is also working on the Assemblyline team. So today we're going to walk you through what is Assemblyline, but we're going to do so in basically looking at some malware samples and try to highlight some of the features that Assemblyline has, and you might also get some ideas of how we use Assemblyline here in Kansan Cyber Center. So to start, let's introduce the Canadian Center for the Cybersecurity. We are the Canadian National CERT. We're also part of the Communication Security Establishment. So our role in the CCCS, that we call, is to inform and protect Canadians, but also to develop tools and technologies and help defend networks in Canada. So today we're going to talk about what is Assemblyline. So Assemblyline is a scalable file analysis system. So it's a system that is main purpose is to do triage on files. So to get the files that you have in your network, either entering through emails or web gateways, other places where there's files coming in, and send them to the system where they're going to be analyzed and scanned. The system scale, and we're going to talk about that a bit, but it can go over like multiple million of files coming in a day. Its main purpose is to automate the analysis for incident detection, but also to help incident response team, forensic team, so anyone that have files or malware. One key thing with Assemblyline is it's easily integrated into existing ecosystem. It is a open source system. So it's been, the version 3 of Assemblyline has been open source in 2017. And we've open sourced the latest version, which is version 4 in 2020. So having the system open source allows us to allow people to integrate it within their own ecosystem and to tweak it to their own need. So let's talk about open source a little bit before we dive into the tool. So the CCS believes that cybersecurity is a team sport. So we believe that community's tool and standard help us work together. So attacker works together. Defender needs to also work together. And sharing tools and signature format and standard is one way that we can work together. So that is one of the reasons why Assemblyline is open source. But we go beyond just making the tool open source. We also contribute heavily to many projects. So the ones that are below are just a few of the ones that we are contributing to. We're really trying to improve the tools based on our operational knowledge of using them. And Assemblyline helps you integrate, scale, and maintain the community best tool with our operational knowledge. So we take care of making sure that open source projects that we integrate into Assemblyline are like kept up to date and are doing at their best. So what is Assemblyline? So in terms of the system, it is a Kubernetes stack. So it runs on top of Kubernetes or micro-KDS. There is also a Docker Compose deployment for smaller appliance. It's built on top of open source technology like Elastic, Redis, Unicorn. So we use Elastic and Redis for queuing files and also for storing the results and making everything searchable in the system so you can pivot on things. And then there is many different analyzers. In Assemblyline, we call them services. And what you're seeing scrolling there is just a list of some of the services. All of them are on GitHub. We won't be able to go over every single service today, but we will highlight some of them for the malware samples we're going to be looking at. But there's a very wide variety of technology available as part of the SMLine ecosystem. So SMLine is designed to handle all of your file, all of the file coming into your environment. So that can be, if you can see on the left there, it can be places like emails, attachment coming into your environment. It can be file download through gateways. It can be file from your EDR platform, or it can be to support analysts, incident response, or forensic teams. So the idea is that Assemblyline will centralize file triage, scanning, but also enables you to integrate commercial platform into it, such as antivirus, sandbox, and other security product. So you can integrate those with Assemblyline. And you can also import all of your rule sets into the tool. So either open source or commercial Yara signatures, Circata, and also Sigma signature. So with all this, when files come into the system, Assemblyline is going to support a wide range of file types. It's going to have different analyzers for different file types. So depending on the file type, different analyzers are going to be used to scan your file. One of the key goal of the tool is also to deobfuscate and extract IOC. And you're going to see a bit later why it's important. But the goal with Assemblyline is not just to say a file is malicious. It's more than that. It's also to extract useful in cases of compromise so you can build some automation later. So files are scored, and there's heuristics and tags. We're going to go over those. And the analysis is done recursively. And the output from the systems are alerts, indicators of compromise, and also powerful REST API that you can build and automate things like any ideas that you might have for your entire file collections. So let's take an example that I'm sure it has happened to nobody here. So once upon a time, on a Friday at 4:30, as you're planning to leave for a long weekend, there's a new alert. And you happen to be the one that's in charge that day, or the one left in the office. So let's look into an alert, what it looks like in Assemblyline, and let's take it from there. So this is the alert perspective of Assemblyline. This is just the list of alerts. Here, there's a single alert. So what you're going to see here is the number of times that this file has entered your network. So if you're sending all of the files you have and you do the collection, like I mentioned previously, you're going to know many times or many users or many machines have seen this file. It has a file type. It has the labels that analysts would have applied on the alert. And it has a few detection like counts to give you a rough idea. Also has the Assemblyline verdict. So if you click on the alert, you're going to get more information. You're going to see there is alert information, so ID, times, things like that. You're also going to see metadata. So along with the ingestion of your file, you can include like metadata that suits your needs. In this case, we have just like SMTP, and it's going from totally legit email and it's going to a Mr. Click-a-lot. So yeah. They also have the IOC to act upon. So there's that. There's a URL there that was extracted, and heuristics that were flagged. So you can see files infected. That means there's some antivirus hits on this. There's some batch files, there's network IOCs, there's archive involved, and yeah, a few things. So clearly, this looks like something bad going to a user. Assemblyline also enables you to do automation on alerts. So there's something called workflow action. And what this allows you to do is to build queries like this one, and build queries that will apply labels. So the idea is that you can build different queries for different, like it could be a phishing campaign, could be like other things like that. And you can apply whether it's a malicious, false positive, the priority, and also labels. The labels can be user-defined. So in this case, we're applying the phishing label. And Assemblyline will then automatically execute this query on any new alerts coming in. So the labeling is going to be automated from that point on. So before we go further, let's introduce some key concepts. So Assemblyline, one of the first view you're going to get when you look into a file is the submission report. The submission report is kind of the TLDR of the analysis. So it includes a summary of the entire analysis tree. It includes the system verdict. It includes the error rule, like we have a few error rules here that have triggered, highlights, indicators of compromise, which is what we're seeing right now. And the report is fully printable. And you also see the attribution if there's a error rule that was able to attribute this sample. So in this case, we're looking at what sample looks like. Another thing that's important is the heuristics. So the heuristics, basically, their goal is to help to score a file. So the heuristics are responsible for scoring. But they're also responsible for highlighting malicious element of a file. So in this case, what we're seeing right now, what I open, are like 3 different heuristics. It's going to replay right now. So you have the full submission score. In this case, we have like close to 6,000. And then what you're seeing there is all of the heuristics. So like some AV, it's like we have a single link file into an archive that's kind of strange, a weird command line. The heuristics, like I said, also have like a maliciousness level. So that's based on the score, and that's how they are colored. And they are also fully searchable. So you're able to build queries to find new things, basically, that we might have missed. So if we go a bit further into heuristics, so each of the heuristics have an ID, which can be queried on. They also have a name, and they have a description, some details. So okay, so in this case, this was the file that was a single file that was in the archive, and they are color coded based on the score that was given to the heuristic. So another key concept beyond heuristics are tags. So all of the bubble type of labels that you're seeing there on the screen, they are all tags. The tags can be clicked on to highlight where they are present in the file tree. So that's what you're seeing in blue at the bottom. Depending on which tag I click on, that it tells me which file is present inside. And you can also search on tags. So if you have, in this case, I have a static URI, and I can find any other files in the system that have the same URI inside of them. So it might help you to pivot on newer files that would not have been detected, or maybe they were not detected at the time that they came in the system. But But that is not just true with URLs, it's true with any tags, and they can be combined together in a Lucene search query. So kind of Boolean, mostly Boolean search syntax. So and this, or and then wildcards and other things like that. Yeah. So if we look inside the actual analysis that was done here to generate the alert that we saw at the beginning. So I mentioned that SMLine does its analysis recursively. So what that means is when a file is submitted, in this case, what was submitted to the system is the top one. So if we see here, it was a HTML file. The HTML file is going to be dispatched to like any services that can analyze HTML file, or any services that will analyze any file, like Yabra or Stars. And as those services are doing their analysis, they might extract other elements from a file. So in this case, something that makes a lot of sense, like from a HTML page, we extracted some JavaScript code. And then it kind of goes sideways. So we go down to a zip and then a shortcut and batch. And so that is interesting. Yeah, exactly. So if we jump into the file detail, we will see, I'm looking at the HTML file here. So the HTML file, we know the type, we know the number of times we've seen it, the first time we've seen it, and we can also see the content of the file. So in this case, this is the JavaScript that was found. So we can look like some obfuscated JavaScripts. And interestingly, there is also a password. So more on that a little bit later. So the file view will allow you to look at the hash, the types, number of times you've seen it. It also has the ability to let you download specific file that were extracted. One thing that is nice for corporate environment is that any file that you download from the system will be inserted in the cart format. So what that means is people can safely, like your analysts can safely use the system. And if you need to go and take the file and take it to a reverse engineering environment, let's say, you're able to download it. It will be safe. There's no chance you actually run the file on your computer. It will not trigger antivirus and other tool security product. And then you can take that file, move it into your offline reverse engineering environment. And then there is a Python package called cart that you can pip install, and you can just uncart the file, and it's going to give you back the original file, which you can start to do your analysis on. So if we look into the second file that was extracted, we add some JavaScript. So JavaScript is analyzed by a service called JSJaw. And what it does is it tries to do emulation on JavaScript. So as you can see here, it's not really readable. So it's like it would take some time for a reverse engineer or someone like a malware analyst to look into this and to like figure out what's happening. Luckily, JSJaw was able to basically extract a zip file. So it emulated the JavaScript and found that there was embedded in there a zip file. That's what you're seeing at the very bottom. So any files that are extracted are going to be put at the bottom there, and they're going to be resubmitted into the system where, depending on the file types, there might be a completely different analysis that will be done on them. So yeah, so JSJaw gave us a zip file, which is pretty cool. So a zip file will be handled by the extract service. So the extract service, its only goal is to take archive or like ISO files, like some HTML and basically any kind of archive format we try to support them in our extract service. So what the extract service will do is pretty simple. It's to extract the content of the archive, and we've seen some pretty interesting thing recently with ISO file. Like people have started to use weird format of ISO files, like DF files, and bootable ISO file, which cause all sorts of problems. But they are now well handled in Assemblyline. That's fairly recent. So if we look into the extract analysis here, what we can see is, yeah, one thing that is pretty interesting is that extract actually use the password that I shown you in the HTML file at the beginning. But if you remember, there was HTML and then JavaScript and a zip file. So one trick that Assemblyline has up its sleeve, and this is getting more and more common, where the like password are not just in the email, but they're actually in attachment themselves, is that Assemblyline will be able to compute word lists, which are then going to be used to brute force password down the line. So it pass down these words to subsequent services in a side buffer. So in this case, we were able to use the password from the HTML and extract a link file. We also flagged that this was suspicious because there was just a link file in I think this was it was just a link file in a zip file. So link file or Windows shortcut are analyzed by our characterize service, which mostly run EXIF tool and a few other tools like link parse that we're seeing bottom there. So characterize is a service that generate information about like documents. It will generate entropy and any metadata that's embedded. So that could be a Word document, but in this case, this is a link file. So what we see here is the link file as a command here, which has a bit of obfuscation. Not that much, but just a bit. Because remember, this was in a zip file which was password protected, so there's not big need to obfuscate this. So we can see that the person actually wants to mimic as MS Edge, so that's what the end user would see. So it borrows the message icon. And we can also see that there's a suspicious command line. So this is a heuristic that the characterize service has raised and flagged this command line. So the next service in line to analyze the extracted Windows command is batch deobfuscator. So batch deobfuscator will actually deobfuscate batch files that are pretty obfuscated, but also analyze the content of some type of commands that are of interest. So in this case, it found that there was a curl command in the command, and it wrote the destination where the content will be saved, also the URL, which is kind of what we were after. So not only we were able to like find the URLs, but we were able to find it in a context that is suspicious. And that's why the system was able to highlight this URL as being well, you're seeing orange. So that's a suspicious. That's because there is a heuristic along with the URL that is that this heuristic is has a certain score to make this URL suspicious. So yeah. Another nice thing is we have a new service which is called URL Downloader. And what URL Downloader is, it will, if you want to, that's something that needs to be enabled when you submit the file. URL Downloader will attempt to go fetch anything that is hosted at URLs that have been flagged by other services that are suspicious or above. So in this case, because this is a suspicious URL, URL Downloader would try to fetch this payload. In this case, it couldn't get it, so it didn't continue the analysis. But if we were able to actually fetch something, we would actually continue the analysis and go deeper into it. So we've looked into the alert. We've looked at there's something that's about to ruin someone's weekend, maybe. We've looked into all the analysis was done. But one really key thing to Assemblyline is its powerful REST API. So Assemblyline has a REST API. I've shown you mostly the UI so far. Everything that is done in the UI goes through the REST API, so it can all be done via the REST API. It has a vast set of function to send, like, ingest data into the system, to submit data. Like searches, pull files, basically do any kind of an automation that you might want to do with files coming into your network. So this is just one example. If you remember, we have an alert. This is a little bit of Python code that just looks into the analysis that the analysis that was done, the submission that we just went over. And what this code does is very simple. It just parses the data that's stored within Elastic, and it extracts the URLs that were found. And the idea there is that if you have ingestion in place into your system, if you have a workflow where analysts are labeling certain things that you might want to trigger certain action on, then you're able to build some automation and potentially save someone's weekend by blocking domains or taking other action on your network. And all this automatically. So you've got a chance to click and block something before somebody actually clicks on a malicious file like the one we just went over. Without the deep analysis that Assemblyline does, however, we would not have got this URL because if you remember, it was within a zip file that was password protected. So other security product that I know would have flagged this file as being malicious, but might not have give you the IOC that you need to action. So a few other highlights that Assemblyline has. So I went over a analysis, but Assemblyline is a full-fledged platform to basically centralize all of your file analysis. So it will allow you to import your signatures. Signatures are pulled from Git repository. You can use your own private Git repository or use some open source one. It supports many kinds of different signatures that will be applied at different times. So, for example, CERT.LV signatures are network signatures, and those can be quite handy for sandbox PCAP analysis. Or if a user submit a PCAP, it might be an easy way for them to get the CERT.LV hits on a specific file. Same goes for Sigma. So Sigma are quite useful for analyzing Windows event logs and other type of logs. So whether Windows event logs are collected by your sandbox, or if a user submit Windows event logs that might have been collected from a forensic case, let's say, and submit it to Assemblyline, it's going to be able to apply Sigma rule on that. And also config extractors. Assemblyline will build metrics around all of the signature, but also the heuristics. And you can monitor how they're doing over time. If some are starting to cross some false positive and creating too many alerts or things like that, it has all of that built in. Another key thing that I couldn't show during the demo is it has a built-in safe list. So what that means is if you have sources of known good hashes, for let's say, like NSRL, you're able to import that in the system. And Assemblyline will skip the analysis on those files. You can also mark some IOC or tag, like the tags I was talking about, as being safe. So the example I took was fairly clean, but there are cases where there is a lot of, just like if you take an XML file, for example, there's going to be a lot of RFC URLs and other URLs embedded that are not malicious. They're just standard part of the XML format. So SMLine gives you the ability to safe list those, and you can do that through regex as well. And what that's going to do is it's going to show them as green, like what you're seeing in the bottom. But you can also hide them completely. So it's give you basically a tool to clean up the report, and also potentially avoid trying to block, like I was saying, some domains that are not malicious. Another nice service that is part of SMLine is the malware config extractor. So SMLine config extractor, it doesn't do the memory dump itself. So it needs either like a sandbox to do the memory dump, or other tools, or if you can submit a memory dump directly to the system if you want to. But we took an approach where we try to integrate the community's best format. So the service will accept extractors written for CAPE and WCP, and also our own format, which is called Mako. You can have a look on the Cyber Center's GitHub page for Mako. One of the key elements for Mako is it standardized the output of the extractor, which is really important when you want to build automation. If every extractor is using a different terminology, it makes it really hard to know, oh, this is a C2 and this is like something different. So Mako has a strict ontology, which means that we're able to tag and label things very well. But it supports all three. So yeah, without further ado, I'm going to introduce Kevin HardyCooper.
Hey everyone, my name is Kevin. Thank you, JP. As you can see, Assemblyline is pretty awesome. And in the news recently, Microsoft released that macros are no longer enabled by default, which is great for the cybersecurity community. Possibly not good for threat actors. So they have to adapt. And so the next big question is, what are they doing next since macros are now disabled? Well, we've noticed in Assemblyline that these threat actors are using archives, specifically non-zip archives, such as ISO files, VHDs, VMDKs, some subsets of ISO files called UDFs. And we're seeing a lot of these files in Assemblyline being submitted for analysis. So as you can see on the screen, there's a query that is in Assemblyline that I made, and you can just look for all these different archive files and the ones that meet the classification of TLP white. And here are the results. There's 365, that's one for every day of the year, but we've seen these in the last 2 months at least. So I suspect there's gonna be a lot more in the future. So we're just gonna cherry pick one and deep dive into it for the presentation. So here's one, it's an ISO file. It's the 1FC7B hash that you see there. And this is a brute Bretel C4 malware. And it uses DLL sideloading within an ISO file. So we're going to talk about DLL sideloading a little bit later. But right now, this is the structure of the ISO file. You got, the main ISO file, and then these are the indented files are the ones that are found within this file that we were able to extract. So we have a link file. We have this unknown file called OneDrive update, possibly encrypted. That's why we're not able to find out what type it is. You have this version DLL. You have a version DLL. And you have a OneDrive updater exe file. So just right off the bat, by looking at the files that are within this ISO, and there's an exe and there's a DLL, this possibly could be DLL sideloading, which we're going to talk about later. So let's start with the link file. So when we analyze the link file in Assemblyline, we see that there's a suspicious command line argument. This is done in the characterize service. And it looks like the link file opens command exe. we're able to extract the batch file from this link file, and using the batch deobfuscator service that JP was talking about earlier. And this batch file contains just a quick little command called start and OneDrive updater.exe. So OneDrive updater.exe is the file within this ISO, and it seems like the link file just tries to run this file. So something interesting of these files within this ISO being used for this malware are that there are some legitimate files and some illegitimate files. So the first three, the ones marked malicious that Assemblyline was able to identify as malicious files, those are illegitimate files. So those are used for malware detonation. And then these two here marked as I for informational and not M for malicious. These are actually legitimate files that we were able to find in our safe list, and are actually files used for Microsoft signed products. So just a high-level overview of what DLL sideloading is and how it's integrated into CAPE. CAPE is a dynamic analysis environment that's open source, so you can find it on GitHub. It's a sandboxing tool. It focuses on config extraction and payload extraction. It's a fork of the Cuckoo sandbox, which was a very popular open source tool, which is now no longer maintained. CAPE is actively maintained, so CAPE has a lot more features than Cuckoo did. We use CAPE in Assemblyline in order to analyze files dynamically, and CAPE does have support for DLL sideloading. Prior to us seeing all this influx of archive files, however, CAPE only supported zip files as the archive file to be analyzed for DLL sideloading, which doesn't apply to these archive files that we're seeing that aren't zip files. So there's an area of improvement there. All right, so this is the general process of how the files within this ISO file that we saw and how they interact with each other. So we have the link file. It's running this command where it starts the OneDrive updater.exe. Note that this is a relative path, not an absolute path. So the link file needs the OneDrive updater.exe to be in the same extraction folder as the link file in order to actually work. So the link file runs, it starts the exe, and the exe is legitimate. And so here is where the DLL sideloading happens. So the exe normally would load its DLLs from the System32 root folder, but the exe is also lazy. So it looks in the folder where it was extracted to. And if there's a DLL that matches the same name as the one it's looking for, it will use that one instead. So that is where this malicious version DLL file is being used. And so the exe loads the DLL loads its malicious function and then runs that, which then looks for the OneDrive update encrypted file, which is in the same folder. So it'll decrypt that. It'll then use that information in order to inject a process and beacon out for the next stage of the payload. So DLL sideloading is a great anti-analysis technique, because if you're using a security tool that extracts files from an archive, such as like zips, ISOs, UDFs, VHDs, etc., and so you're using those extracted files, and then you're analyzing each file in isolation relative to the other extracted files, that's not going to work with these samples, because these files are heavily dependent on each other being in the same extraction folder or being in the same environment. So this was an issue with Assemblyline before, when we were seeing these files come in initially, because we would extract the file, we would receive the archive file, we would extract the files within the archive, and then we would submit each one to dynamic analysis or our CAPE sandbox, and then, but they would be in isolation. So the link file will get sent to CAPE. The link file we know uses that command that looks for the exe, and that exe doesn't exist in the CAPE environment, so this link analysis result would not give us what we want. Then we would extract the legitimate exe to CAPE, and this is legitimate, so it doesn't do anything interesting. And then we are looking for and then we submit the version DLL, so that's the other legitimate file in the ISO file, and we would send that to CAPE. That does nothing interesting because it's legit, and so this doesn't give us what we want. And then we then submit the version DLL, which is the illegitimate DLL file, And so this file only executes its malicious function when it's being loaded into an exe, and cape doesn't do that when it's running DLL files, so this won't give us what we want either. We don't submit the encrypted file, the OneDrive.update file, to cape because we're unable to identify it correctly, so we don't know what application to actually run it with. All right, so that was the issue before, and this is how we addressed it. So cape did have the option for submitting a zip to, or submitting a zip and analyzing zip, extracting into a folder, and then executing the first interesting file that it found within that folder. But there's an issue, there's a bunch of issues there. So the first issue is that it only supports zip files, and now we're seeing non-zip files. The second issue is it would only run the first interesting file. So if you had more than one interesting file in the extracted folder of the zip file, say for this sample, we have one exe and two DLLs. If cape just found the first, say the legitimate DLL, and then that was the first one that we would find that would be deemed interesting, it would run that, and then nothing would happen, and the analysis is over. So we wanted to run all the interesting files in the archive, so then we'd be able to get all the different possibilities, and we'd be able to hopefully eventually find the path in order to execute the malware correctly. So something that we built out is generic archive support. So this is a package that you can use in cape, and it supports all these different, basically any archive that can be extracted with 7-zip. And we also run all the interesting files within the extracted folder of the ISO file or the UDF or the VHD. And then we're able to, all within one submission. So it's no longer run in isolation and everything is going according to plan. So this would look like this inside the cape analysis environment. So say the DLL is the first in the folder extracted, we would run that. This is perfectly legitimate, so this would do nothing. Then the malicious DLL would run. This requires to be loaded into the exe in order to actually do the malicious stuff. So that wouldn't give us what we want. Then we would try to run the exe, which now is able to access all of the DLLs that it needs. And the link file also points at the exe. So these both are execution paths that would both load the DLL, the malicious DLL using DLL side loading, and then this would decrypt the encrypted file, which would then beacon out. And there's that beacon that we're able to see. So awesome. So this is good, and that's good, and this archive support is good. And believe it or not, this is actually available in a Cape sandbox near you. So this has been released to open source. It's available right now. If you don't use Assemblyline plus Cape, you can just use Cape, and you're able to actually get this functionality in whatever dynamic analysis environment you use. And yeah, so that's wrapping up that presentation. We're from the Assemblyline team, JP and I. If you look here, this is the email address for the official way to contact us for any queries that you have. The link below is the link to our documentation. And if you have an informal question regarding like technical problems that you have, we have a Discord chat, and the link to our Discord is at the bottom of the documentation main page. So thanks for listening. If you have any questions, let us know.
All right. Thank you for the presentation. For sure, let's start with the, there will be one question from the audience. So if you can get the microphone here to the first row, please. But I'll start the questions from my side. So you've invested a lot of time, your team, to develop the tool. However, this is just a software. Can you tell us about the hardware requirements that might be there for me to start using it? If I say, okay, I want to deploy this now, what would be the bare minimum hardware requirements that you would say, hey, this is what you would require?
Yeah, so can you hear me? Just,
yep.
Yeah, good. Excellent. So the minimum hardware requirement is a single server would do just fine. It needs a lot of memory because of Elastic, and we need to launch many Docker containers. But you can do that on, I don't know, maybe a 64 gig, like hopefully maybe some Xeon CPU, like yeah, like a decent server would be ideal for low volume or also to support a SOC team. If you want to use this, though, as the center of all of your file instances for an enterprise, you're going to need something larger. So what this means is probably a community deployment. That being said, SMLine has been developed in the cloud. So if you do have access to a cloud tenancy, that is a very viable option. We've tested it on multiple cloud provider, and we operate some deployment on there as well. So yeah, don't know if that answered the question. We have more detail on our documentation page as to like minimum spec, but expect a need for a good amount of memory and a decent CPU for a single deployment.
All right. Yes, you gave the explanation for sure. So you're using multiple tools, right, to automate, and this is where the assembly line comes into the term or the name that you gave. So Assemblyline will go and iterate over the tools, if I understood right. Is there a particular sequence how you would run those tools, or you would just submit the sample at the same time and do the parallel analysis, or you will wait until one tool produces the results and then feed those results into another tool? How does this work from the behind the scenes?
Yeah, so the way this works is services, we didn't go into that level of detail, but services have a stage at which they run at. So if you set up an Assemblyline system and you look into the services, you're going to see settings where it's the stage. There's other options as well, whether you want to give that service internet access and things like that. But what the stage will do is it will determine in which order it's going to get the file in. So we have some filtering service, for example, the safe list is going to run first. And it's going to look if a file is safe listed, and then it's going to stop basically the processing of that file if it is. But we have other stages like the main stage, and then secondary stage, and then the final stage. And if you run at a later stage, you have the ability to look into the results that were produced by the previous services before you. Just to give an example, the URL downloader service that I mentioned, where if there was a URL that was found and it would go try and fetch it, that service run at a later stage, so it's allowed to like see the URLs that might have been extracted before it.
All right, thank you. I mean, you gave a very, very good, precise explanation and answered my question for sure. Now, not always what we need to analyze is going to be the malware, right? It might be a benign file, but we don't know at this stage if that is malicious or non-malicious. Because the adversary might be just abusing and living off the land, abusing the actual just software that is residing on your system. And if I throw this file into the assembly line, it will at least give me the behavioral analysis that I can, as an expert, afterwards analyze and figure out if that is something that can be abused or not. Is there anything that can more help me to identify the use and functionality even of the benign files from the assembly line? Not just saying, hey, this is malicious, but hey, this might be abused by a malicious threat actor.
So there's been attempt in the past to scan, for example, Docker container and other type of like files that include other files embedded inside of it. Assemblyline is really geared towards analyzing, like finding the needle in the haystack. For binaries, we're going to rely a lot on the error rules. Sometimes the behavioral is going to work as well, like in terms of running the file in the sandbox. One thing that I didn't say and probably worth mentioning is that we don't run every file in a sandbox. Assemblyline doesn't do that because it's very costly to do so. You have actually ways of configuring what you will send in your sandbox based on what the static analysis was, the result from the static analysis. Assemblyline, though, will find URLs and other elements, but for a legitimate file, it's most likely going to come back with no heuristics, some information, some things that might be embedded. but in theory, it should come back with like no score at all or a really low score. There are some heuristics that are to trigger the sandbox, for example, analysis, where it's weaker in skaters, like using PE, editor information, and other things like that. But to identify legitimate file, that's yeah, we don't focus on that.
All right, we'll take the last question from the audience. So there you go.
Hey JP, it's Captain Sharman here from Canada. Nice to see you again. Just had a question. Obviously, Assemblyline is you know, an analysis tool for files and et cetera, and you really use Sandbox. But so right, obviously we used your version, you know, CCCS's instance of Assemblyline. But even for this applies to anyone who just has to build their own. Over time, you're going to have multiple IOCs that you're going to flag as malicious over time, right? Is there a way, a really good way to do bulk kind of IOC lookups on Assemblyline? You know, you can use the API and use the search feature, but that would, you know, you have to do individual ones, and if you have a long list, you maybe not want to do that. Is there a way to do like a kind of a bulk lookup?
So yeah, our solution to that is to use the REST API. I assume you're talking more of a UI way of doing that. So if you had a list that was maybe commiserated, if you could just like put it in and see what comes back.
Exactly. Yeah. Like any way to do anything other than individual lookups, which kind of bog down the server as well, right? Yeah.
No, we currently don't have a way to do that. We're looking at a way to submit multiple files together, but it's not what you're asking for. Really, what we would do in that case is build a very, very simple script that just do the search and iterate over your list of items.
All right. Right. So it seems like there's a feature request from your fellow Canadian members as well. Well, JP and Kevin, thank you for joining us today. I know it's early morning. Well, it's morning on your side. It's already afternoon here. So I do appreciate you being awake that early in the morning and coming here and joining us here in the studio. With this, thank you and applause from the audience. Thank you.